All right, line D7, learning task number 1, describe hazardous locations. And this is once again going to be another piece of brand new learning guide that hasn't been put out years previous. You guys are one of the first groups that's going to have gone through it in the prevents over here. It's always been a requirement of third year that hazardous locations were taught, but it was never a formalized thing. And so what a lot of instructors would do for third years, they would just go and dump a whole pile of Canadian electrical code questions on you without, giving you any sort of an explanation. So now we finally do have a bit of a module with a bit of explanation. We're just going to go through it here. One of the first things that we're going to go and talk about is just what the whole point of this module is. And the whole point of this module is that you are going to be able to describe hazardous locations, and you're going to be able to go and identify them. You're not going to be able to necessarily engineer them, and you're not going to be the one that's going to be responsible for making the final determination for them, but you should be able to describe them and therefore be able to recognize them and maybe just put the brakes on when you hit some place where you're like, well, maybe I just got to hold on here. Canadian electrical code has always been stringent on areas that have a greater hazard index. So areas where we're going to go and have an explosion are typically going to be places where we're either going to go and have explosive gas or explosive gas, dust. And since 2012, I think it was, we had, maybe even earlier than that, but we had two major forest mills, wood mills, upcountry, blow up Babine, and another one that was out there in the Kootenays, I forget the name of the other one. But there was a total of 4 people killed and about 40 people injured across those two incidents. Which means that since then, dust in particular has been something that has been tracked really carefully by your technical safety BC officers, as well as just by the industry in general, because for a lot of years it was kind of just ignored and like, yeah, dust can be explosive, it's not going to do much, and then we had a bunch of deaths and millions of dollars of damage, and then a whole pile of injuries as well. So since then, we have been much more stringent in the province and actually nationally on dust as well. Reducing a chance of ignition is going to go and help us. We're going to go and reduce chances of ignition by making sure that we have got safe electrical apparatus and that it is being maintained safely, 2 separate things. First thing that we have to do, though, is we have to identify when we're in a hazardous location. If I don't identify the location, I won't know what I'm necessarily supposed to go and do. And then once I have identified it, I actually have to go and follow the rules. And the rules are going to be expensive. Hazardous locations do require specialized electrical devices that are going to be expensive. You're going to talk to some people then, particularly industries that have been around for a long time, wood mills and things like that, and they're going to say, well, we never used to have to buy these, and these switches or contactors are, 6 times the price of what they used to be, and I don't get why we're doing this, I'm going to find another electrician. Don't buy into that. If they're not willing to pay for the proper level of safety for their installation, you don't want to be the one that has signed off on it and is going to be responsible when that thing eventually goes up. So make sure you actually go and abide by it. The classification is usually going to be done by a professional engineer, not by the electricians, but by somebody that is involved in that project. All of our wood mills are going to be required to have a professional engineer that's going to be creating a safety plan for them in the province. It's a relatively new thing since the 2012 explosions, but we have to go and have these CDH, or combustible dust hazard plans, that are going to go and be followed. CDH, It'll make it any more sense when I write it like that. Let's do it like that. CDH, that is going to be their combustible dust hazard plan. These are going to be placed out by an engineer who's going to go and class the different areas inside of them. Classification can sometimes involve more than one type of engineer. If we have got electrical, we're going to have electrical engineers. We are going to go and have HVAC. We are going to have boilers, process engineers, etc. A whole pile of stuff like that. Once we know that we've got a hazardous location, we just have to determine exactly how hazardous it's going to go and be. And there's going to be 2 main things that are going to determine how hazardous something is. First thing is going to be the type of hazard substance. So is it going to be a gas or a dust? And the second one is going to be how often or how likely is it going to be that I'm going to go and see this hazard exist. Inside of our 2018 Canadian Electrical Code, we changed from being class and div to being what we call zoning for all of our hazardous locations. And zoning is going to go and follow 2 main things. We're going to go and have either a single-digit zone, which is going to go and indicate that it is going to be a gas type, single digit. And if I've got a double digit, double-digit zones are all going to go and be dust types that we're going to be looking at over here. If I take a look at them, I see that I go from a zone 0, which is going to be the most dangerous, where I'm going to have gas that is present continuously or for long periods of time, over to a zone 2, which is gas that's not likely to occur in normal operation, but if it does, it's going to be for a short time, or it's right next to a zone 1. Obviously, if I'm a zone 1, the area next to it would have to be classed as being an area that could sometimes have it because gas could leak out of the zone 1, etc. We're always going to go and have concentric rings. If we do have a zone 0, we can never have just a zone 0 by itself. We are also going to go and have around that zone 0 a zone 1, and around that zone 1 we have to go and have a zone 2. Because here we know there is explosive gas inside of that 0, so it's very likely it's going to be out here, but as we get further out, it's going to be less likely that it's going to be that far out. Our dust is going to go and follow the same sort of tiering. I've got a 0, 1, and a 2 over here, but we just now preface them with another 2 in front. So it's a 2, 0, a 20, a 2, 1, a 21, a 2, 2, a 22. Once again, present continuously is going to be the 0 identifier, and not likely, but could sometimes happen, is going to go and be my 2 as well. If you go into your Canadian Electrical Code Handbook, there's going to go and be some more designations, for how many hours a year that we can go and expect these things to go and happen. Let me just pull up a copy of that for a second. Just give me a second, we'll just pull up this handbook here. Canadian Electrical Code, there's a handbook that goes along with it. It's another $300 book that kind of explains some rules, gives it a little bit more detail. We're just going to go down into that one there. We've got Zone 0, Zone 1, and Zone 2. And it's going to give us a bit more detail in it. It says, well, there's no firm rule relating to explosive gas atmospheres that persists in Zone 0. The rule of thumb is that if it is above the LFL, that's going to be the lower flammable limit, or the amount that it's going to take for the sucker to blow up. For more than 1,000 hours per year, the area is going to be a Zone 0. And then if I go to my Zone 1, it's going to be less than 1,000, but more than 10 hours a year. And then if I go to my Zone 2, this is going to be less than 10 hours per year. And they're going to go and give you, just a couple of little examples for each of those. Let's put them back onto what we have over here. This is going to be long periods of time, 1,000 plus hours. This one here is going to go and be 1,000 to 10 hours. 10 hours is not a lot per year. That's really, the duration of a maybe 1 or 2 small flammable liquid, spills or something like that, because that stuff takes a while to go and dissipate. And then my Zone 2 is going to be under 10 hours per year that we're going to go and have. Same with my dust inside of here. We're going to go and see a similar type of thing. Our Zone 20, 22, etc. Frequently, and then occasionally, and then short periods of time. They don't give it to you inside of this one over here, but they did have inside of, I don't think they still have that one inside here because they've updated since, but they did in previous handbooks go and follow the same one, that, if it's present continuously, long periods, was going to be that same 1,000 hours, then 1,000 to 10, and then underneath 10. So we need to go and take a look at, is there going to be gas, gasoline, diesel, hydrogen, flammable gases of some sort, or is there going to go and be dust that are going to be inside of here? Because we have got this zoning that is going to go and follow rings, a Zone 0, out to a 1, out to a 2, and then after that to an unregulated type of area. We're always going to go, if we have any of these zones, we don't necessarily have to have a Zone 0. We can start sometimes with a Zone 1, where it's going to be likely to occur in normal operation, it's 1,000 to 10 hours a year. We could start with a number 1 zone and then go over to Zone 2, but as soon as we have a higher value zone, we're always going to go into the lower one. Same as we can have a Zone 2 on its own, but we can never have, because outside of the Zone 2, it's going to go into, an unregulated area. But we can never have just a Zone 2 and a Zone 0. There will always be a Zone 1 in between or something like that. We've also got subdivisions of our types of gases that we are going to go and have that are going to get ranked according to groupings then. So I've got Zone 0, which is going to be how long these things are going to be, and then I'm going to have grouping, which is going to be types. So I'm just going to go and write this here. Time, that's what the zone is, this column over here, and this is going to be type, what the thing is. So if I take a look at my groupings up top here, I'm going to just go and highlight the top one over here, hydrogen. Hydrogen is a super light, super explosive gas that, it gets generated during battery charging and a bunch of other industrial processes. It is going to be classed as being a type that is a group C. Whereas if I take a look at my type A over here, I see that alcohol is down there. Look at that, our old friend alcohol. Alcohol, as you know, if you've ever gone to a fancy restaurant, they can go on light alcohol. You can get those like flambe type of, foods and stuff like that. I've never had one. They always kind of looked cool, but whatever. The alcohol itself does light, but it doesn't want to go in light. If alcohol was highly explosive, people that smoke and drink would never survive as long as they do. Alcohol can be lit, but it takes a lot more. So it is a less dangerous. Our danger scale is always going to go from here and down. Now, if I have got a zone 0 with a type IIA over here, compared to a zone 0 with a type IIC over here, you should be able to go and class which one of these is going to be more dangerous. First of all, the zone just says how long. Both of these are going to have lots of gas that's going to be in there, but if I take a look at the types of gases, I see that my A is going to be hydrogen compared to my C. So there's a good chance that my equipment that is going to be built for the hydrogen is probably going to be built a little bit different than the equipment that is going to be built for the alcohol, because the alcohol, even if it is present continuously, is going to be just, once again, less dangerous. It doesn't ignite nearly in the same sort of manner, nor does it spread or hit, as good of explosive limits. Our metals are also going to be classed under the same way there. We're going to go and have time and type. I guess I can put that back over there, time and type. Time is going to be 20, 21, and 22, how long we have it. And then type is going to be whether it's going to be a 1C compared to, all the way down to a 1A. And once again, we are going and starting with danger at the top and less dangerous. It's still danger, but less dangerous as we rank down there. Take a look at combustible metal dust. What does an arc burn at? Well, an arc is going to go and burn between 3,000 all the way up to 30,000 degrees. This is hotter than the surface of the sun type of temperatures. It's incredibly hot. So if I have got suspended fine metal dust in the air, particularly things like magnesiums and aluminums and stuff like that, we can get an arc that'll travel through there, and then that arc is going to go and vaporize across there, and you end up with these massive, massive explosions. So it's a really dangerous type of dust. Then we're going to go and have combustible dust that are non-metallic, some of our coal and sugars and stuff like that. And then we move down to solid particles, including fibers. And once again, if you take a look at it, trying to go and light something that is a fiber is a lot harder to do than to light something that is dust. Flour is a great example for something that is a powder that is flammable. If you ever have a campfire and you have a little bit of flour, or pancake mix if you're camping or whatever it's going to be, try throwing from a safe distance, just a tiny amount of it into the fire, and you see that it's just going to pick up. But if you would go and take, something larger that's from the same plant, let's say just a piece of grain itself, and you throw that in there, you'll see that that grain will burn. But because it's a larger particulate, it's a fiber, or it's a solid, it's not going to go and give you the same sort of violent reaction that you would get from your combustible dust. The finer the dusts are going to go and be, the greater the chance that we are going to go and have a explosion off of them. Abbotsford had, a little bit ago, maybe 2-3 years ago, at one of the cabinetry places up by Mount Lehman, there was a small explosion inside one of the bunkers. They had caught fire to their dust extraction system, and then when they were trying to knock down the fire, there was all of a sudden a collapse inside of the bin, stuff that had been hung up that just kind of collapsed down. And when it did, there was just this, fireball that rolled out of it. You can still find some video of that stuff online. It's just a dangerous thing when we get wood dusts that go and combust, because as soon as you get that first explosion is then going to go and lift something up. So you get a small primary explosion, but when it does so, it blasts all the other dust, and when it does that, it lifts all those other dusts and suspends them into the air. And once it suspends them into the air, now you are set up for a huge explosion over top of your plant. Previous to what we had over here, where we had zone, which was our time period that we had exposure, and group, which was our type of exposure that we had class and div. over here. And class and div is not allowed to be used to build new facilities. If you have an existing facility that is operating under the class and div standards, you're allowed to go and use class and div for that one. However, if it's brand new, it has to go to the zones. Because there is still allowance to use the class and div, what they've done is they've created an appendix that is in the back of your code book that is called the J18. And all this is it is the old section 18 that has been moved to the back of the book because the old section 18 used to be on my classes and divs over here. We had 3 classes before. We had class 1, which was going to be gases, class 2, which was going to go and be dust, and class 3, which was going to be fibers, cottons, things like that that are like floating around during manufacture. Gas were then placed into 2 divisions inside of there. So we had typing, then we had division, which was going to be how likely it was to be present. So we had division 1 and division 2. Same with our dust. Division 1 and Division 2 that we were going to go and have, and same with our fibers, Div 1, Div 2. The division was simply a classification of the time, once again. And then inside of that, we would have, again, categorization inside of there. So class just tells us if it's dust or gas. Division is going to go and tell us time, present, that it's going to be there. Then what we had inside of there is we had groupings that were going to be inside of these. And so they had a bunch of different groupings. If you take a look over here, we see that our A type of grouping is acetylene. If you've ever done any sort of welding, oxyacetylene, that is a flammable type of gas. Or you can go and take a look at the next one down here, we see hydrogen. And then once again, we'll go back to our old friend alcohol down here at the bottom. And we see that we are looking at a ranking. We have danger from the top all the way down to the bottom. Class was going to go and tell you if it was gas or dust. So gas or dust. Division was going to go and tell you how long it was going to be there. You like, get out of there. What you doing, bud? And then your group was going to go and tell you the type that we were going to go and have. The type of dust or the type of gas that we were going to go and have. They also, when it came to the dust types, they didn't go and restart, going A, B, C, D. They went to E, F, G all the way through the rest of these ones over here. One thing that I do want to go and note is that there is the differentiation between a class and a group A. A group A is really dangerous, whereas if I go and compare that to my zone grouping, a grouping under zones, an A is not very dangerous compared to your other options over here. Okay, I think that's all that I really want to go and cover out of these ones. Basically, for you as an electrician, you need to know, that your zoning is the amount of time that it's going to be present. The more time, the greater the odds that something is going to go and blow up. And that the typing is going to be defined by your group, your zone and your group. Grouping is always going to be the same, whether we're in class and div or whether we're in zoning. Grouping always deals with the type that we are looking at inside of them. And then the rest of these ones over here, the time is just going to be done off of our zoning, whereas on our class and our div, the time was going to be, where is that one over here, done off of what we refer to as our division, or the division of time that there was flammable gases or dust that were going to be present. All right, note this. Note that anytime that you are working in places with lots of wood dust, that is going to be small wood shops, machine shops, sawdust storage, mills, anything like that, be sure that you are very careful about what you install. And if you're uncomfortable with what's going on inside there, that what you're being asked to go and install inside there, make sure that you talk to your boss, or if it's your own company, that you go and get professional analysis if that's an area that needs to have class and div.